Hi, everyone, and welcome back to the Lattice Thought Leadership Panel. My name is Matt DeBroge, and I lead our segment marketing team here at Lattice Semiconductor. With me today, I have two very close friends to talk about some of the challenges and how we're solving them in the mid-range FPGA market. So with me, I have Gordon Hands from our product marketing team and Ben Beharin, from our moderator from Creative Strategies. So Gordon, why don't you kick it off and tell us a little bit about yourself?
Hi, so as Matt said, my name is Gordon Hands. I'm located out of Lattice's San Jose facility and really spent the last 20 plus years of my life involved in FPGAs, listening to customers, defining products and launching them into the marketplace. So super excited to spend a little time talking about this topic. And with that, over to you, Ben.
Hey, thanks, guys. It's a pleasure to be here. I'm happy to be moderating this conversation. As Matt said, my name is Ben Beharin. I'm the CEO and principal analyst at Creative Strategies. Semiconductors is one of my focus areas amongst many. I've been focusing on semis and studying the market as a whole for over 20 years. And my intro into, I guess, my love of semis started with my first job at Cypress Semiconductor, just getting into the weeds of engineering and designing silicon. And so I'm excited to kind of have this conversation. I say this kind of frequently that I really enjoy talking about semiconductors. I think, there's a fascinating set of dynamics of not just the industry, but the science and even the business and economics. But I think the overall sort of arching interest in semiconductors is often, I think, misunderstood, the impact that they have, but really it's the foundation of innovation that we see in really every category of technology that we look at. And it was fun to talk about FPGAs today. I sort of have this conversation lately that, it's like FPGAs are kind of cool again. And, just having a really broader look at kind of the way that FPGAs have been used before, what makes them unique, and maybe why we're at some form of an inflection point where people who thought, the ways that they used to design FPGAs into their product roadmap or their strategy may very well be on the cusp of changing as well, as we start to go into some new operators and new opportunities. So let's just sort of start with, from your guys' perspective, what is it about FPGAs that make them interesting, and how are we starting to see some of these macro shifts to new opportunities within the category?
Oh, that's great. Thank you, Ben. And hey, I think FPGAs have always been cool, but I think Lattice is here to make them a whole lot cooler. And I'm looking forward to talking about it here with you today. Thank you for moderating for us. So just kind of first, really, I think why why Lattice FPGAs, why FPGAs are, becoming more and more cool is because, FPGAs are, really great for when our customers are accelerating innovation. And if you look at our customers today, the macro trends, the mega trends that are driving a lot of our vertical markets are really industry disrupting innovations. If you look at industrial, customers, if you look at industrial automation, robotics, the need to be able to go down to every one of your industrial endpoints and extract data and then do something with that data with insights, with software and cloud service providers. That is a pretty disruptive new industry trend where FPGAs are a big help for that. If you look at comms and computing, and if you look at domain-specific acceleration, which means there's different types of compute for different types of problems in different places, that's driving a whole bunch of disaggregated server architectures and communications architectures, which mean more connectivity, more places, which is really great for FPGAs. And then if you look at automotive and some of the changes with the electrification of automotive, and there's more sensors now in a car than in any other device, right? And with that comes the need to be able to bridge and extract information from that. So all really great opportunities for this conversation in FPGAs. So Gordon, any additional thoughts just to kind of get the conversation started as we start?
Yeah, you bet. So I think, I always like to start with thinking about, from a developer's perspective, what their choices are for implementing logic. FPGAs are, of course, all about helping people implement logic functions. And really, we can think about developers having three choices. They can use FPGAs, they could use an ASIC or an ASSP, or they could use a CPU. So maybe looking first at ASSPs and ASICs. Really there, I think the ongoing challenge continues to be the time that it takes to develop those products and the cost of developing those products. And really the beauty of the FPGA approach is the chip's already designed for you. So you don't need to spend tens of millions of dollars doing the chip development, and you don't need to spend 1 to 2 years doing that. You get this blank canvas that you can drop your design into and really start to see something working and see success in a matter of days. And I think that becomes even more important given the rate of change that we're seeing in the world, and specifications and standards continuing to move. The other choice that folks often look at is CPUs. And there, the big challenge people have is, how do I get my problem done quickly enough? How do I get this piece of compute done with the right amount of performance? And increasingly, people are finding that the parallelism of FPGAs, particularly kind of mid-size FPGAs, is really beneficial, right? So you can be basically running many calculations in parallel rather than being bottlenecked in a CPU doing calculations one at a time. So, I think lots of really neat reasons for folks to consider FPGAs.
Yeah, and I think Gordon, you kind of hit the nail on the head. What makes them super interesting to me is that they are a blank slate. I think the fact that they are relatively general purpose, customizable, and flexible is some of the things that makes it really attractive to product companies or companies who have a vision for a service or a specific industry that they want to bring solutions to. Because the reality is that buying off the shelf parts from your vast array of ecosystem doesn't always fit your strategic needs. And I get into this conversation countless number of times with folks in the industry about Apple's move to vertical integration. And while everybody has Apple envy, it's very, very difficult and extremely expensive to develop a CPU and a GPU and an NPU and any number of things that Apple keeps developing. Not every company has that opportunity. So the fact that you can use something like an FPGA, bring a form of compute that's got a lot of flexibility and customization, and then really use that to accelerate your differentiation, I think is really exciting. And obviously the way that people have looked at this before, when FPGAs have been relatively limited in their compute and more toward the lower end of the stack, I think now that we're moving toward more mid-range and to some degree high-end FPGAs, all those points that we just talked about get accentuated in their opportunity for people to now take advantage of increased compute, maybe even do more around AI or security, really more with their secret sauce than they could before. So maybe talk a little bit about why this is significant, that we're moving from really just, not that all FPGAs have been in the low end, but that's typically been the way they're utilized, and that now we're on the cusp of this shift more to the mid and the high end of the market.
Yeah, so probably good for the audience. We're talking about mid-range, high-end, small. We should probably just kind of provide a little bit of a compass for folks. So when we talk about FPGAs and the different ranges that we've been discussing, we really organize the product by capacity. And when we talk about small FPGAs, we really talk about FPGAs that have about 100,000 logic cells or less. And the mid-range is greater than 100,000, less than 1 million. And then really the large FPGAs are 1 million logic cells and greater. So just to kind of orient the audience, that's what we're really talking about. And when it comes, I like the way you frame that discussion around customers and the verticalization of silicon as a macro trend out there. Well, with, building larger devices and going into those greater than 100,000 logic cell types of devices, what that does is it gives customers the sandbox, the platform to be able to do more of those types of designs, onto our devices, right? So what that means is, if you are looking to go and create a design with advanced connectivity, with more optimized compute for AI functions, if you're going to try to drive some networking IP, with a mid-range size device, you have the ability to go do more of those things, in this space. Gordon, maybe you could talk a little bit about how designers, utilize, the mid-range FPGA densities and where we can bring some value there.
Yeah, you bet. So, it's kind of interesting. We recently launched a kind of next FPGA platform that's very much targeted at the mid-range. And, before we went into that development, we spent quite a lot of time talking to literally hundreds of designers and developers across the industry, seeing, what their needs were and, where they think that Lattice might be able to help. And there certainly were a few themes that came out of those discussions. So the first one was there's really a hunger for innovation. So what we heard from a lot of the developers is, they were not seeing enough new innovation, enough capabilities being introduced into the market, and they really highlighted kind of an interest in an improvement in a few different areas. So one of the areas that they talk to us a lot about is performance, right? So developers are looking to get the right level of performance of the FPGA fabric, and then of the connectivity around the FPGA in terms of the latest Ethernet and PCI standards, the ability to talk to the latest memory components. We also heard a lot from folks about the need for more power efficiency. So, as people start to use larger and larger FPGAs, of course, naturally those components are going to consume more of the power budget within a system. So the power efficiency really becomes paramount. And it was kind of interesting to hear kind of some of the reasons that people are interested in power. Sometimes it's just a matter of, hey, I want to reduce the power footprint of my device. Maybe it's because they're running off a battery, or they're concerned about the overall operating cost. Sometimes it was around improving productivity for their customers. So they had a piece of battery pad equipment that needs to be charged up, and the longer it can run before it needs the next charge, the more productive that equipment can make workers, say in a factory. And then, the last thing people told us about power is one of the biggest challenges folks face these days is really managing the thermals within their equipment. Sometimes that's because, they've got a pretty limited thermal budget. Sometimes it's because they're trying to operate the equipment in pretty extreme environments. Say, for instance, a bit of wireless communications equipment sitting up on a top of a pole. Sometimes, it'll be really cold, sometimes super hot. And then the last area that people gave us a lot of feedback on was the need to get more functionality into a smaller space. So they're basically asking for help reducing the form factor of the FPGAs. And again, there's some different motivations for that. Sometimes it's because people are trying to produce a kind of really small handheld piece of equipment. And other times it's because they've got a given level of performance they need to achieve. So they want to put, multiple devices within their box. And obviously, the smaller the devices, the more they can put in the box, and more compute performance they can provide. So some really kind of strong desire for improvements, across the marketplace.
Yeah, that's interesting, and one of the things that this makes me think about too, because again, we're talking about the general purpose nature of having a product that's got, again, increased logic capacity, increased performance in a range of vectors, but obviously from a low power standpoint, it really opens up all of the different ways that this can be used now for anybody, right? Starting to design product and design their vision or their differentiation into the project, into their overall products. But when I think about this, what makes me interesting, the more that I've had conversations with you all and just broadly in the industry, is it reminds me of many of the early concepts that NVIDIA would put out around just general purpose GPU compute. And the whole overarching point there was that you've got something in your GPU, and we're going to make it general purpose and provide some software. And the point of that was just, again, letting there be a software stack or a platform that pushes to innovation forward in more of a controllable way, right? And as we have this conversation, it's important to recognize how product companies can be a little bit more in control of their destiny by doing this, right? Control the pace of innovation, maybe increase the pace of innovation if somebody that's providing them another component isn't doing so. And so I think those are all really interesting, but it comes back to a platform-like approach, which to me is always the most interesting way to think about this, right? It's good to be a chip company, but it's even better to be a platform company providing software to make it to leverage any innovation there. So I know you all take a very software-centric approach. I think you think about this philosophically as a platform similar to NVIDIA and others from my chats with you, but maybe elaborate on that. Talk a little bit about more how the two parts of this stack come together to empower innovation for the market.
Yeah, that's a great way to frame it, Ben. And so for us, a platform-based approach is really how we build our roadmaps here at Lattice. And we did this 3 years ago with Nexus, where we launched our Nexus platform for the small FPGA market, and we rolled out a series of different products that were tuned to very specific product swim lane needs, where there was a different balance of resources on the devices depending on what the needs were for those applications. We did the exact same thing with Avant, right? So focusing on power efficiency, connectivity, and optimized performance. What we're able to deliver is that same platform capability that lets us roll out a series of devices that have a balance of different resources depending on the applications that are going to be leveraged by our customers. And then, like you said, the software is key. So when we rolled out our tools and our software with Nexus, and the fact that most of our customer targets for Avant were our Nexus customers, we really made it a critical need for us to have our software be as portable as possible from one family platform to another. So that is what we are aspiring to do with our Avant platform, which is, hey, how do we give our customers solution stacks, tools, and really make using our FPGA platform as easy to use as possible? And kind of going back to your verticalization of silicon discussion, for some customers, they really just want to solve their market problems. They're not as concerned about what is the underlying semiconductor technology as we are, right? So being able to have software that makes their design environment as easy as possible, where you can have the right IPs available to you to be able to build your design, and also be able to move it from a number of different boards, because you're not just rolling out one design, you're rolling out a number of designs, right? So you want to be able to move those as easily as possible between your engineering team. So those are all things that were critically of importance to us when we designed Avant.
Maybe to kind of jump in and kind of emphasize some of what you're saying, Matt, and kind of add a little bit. Absolutely, software compatibility, across the platform and then across different platforms, kind of really key in our thought process. So we're pretty excited that the kind of key tools that developers are going to use are Radeon FPGA software and our Propel processor builder. Basically remain the same as you go from our Nexus platform to Avant. So definitely really easy for people to take their work and port to the latest technology. And really the same is true for the various different software stacks that we build on top of that. So whether you're doing AI or security or machine vision or communications, you're going to be able to take advantage of the different stacks that we deploy and really use those to accelerate your development activity. I think the other thing that's really critical about the platform approach is what it lets us do in terms of silicon products. So when we announced Avant, we basically announced a platform and a set of capabilities, and we're going to be using that to rapidly introduce a whole variety of FPGA families, each targeted at different needs and uses within the market. So as we launched Avant, really the first of those families that we talked about is Avant E. That's very much focused on edge processing. So E stands for edge optimized or edge processing. And we're really excited about what that's going to enable people to do, particularly in the areas of AI and machine vision, two areas that are kind of increasing in terms of usage of FPGAs. The other fun thing is, because of that platform approach, as we announced the product, we really were able to commit to the marketplace that as we go through 2023 here, we're going to introduce two new or additional families. They're going to provide some further capabilities, each optimized for some exciting new markets. So definitely would encourage people to stay tuned for that. Uh, the perhaps the really other part of a platform and something that I think is really critical is what we're enabling in terms of the ecosystem. So one of the really fun things that we did at kind of the end of our launch event for Avant is note that as we get to the back half of 2023, we're going to have our first developers conference. And maybe Matt, I don't know if you want to say a word or two more about that, and then maybe Ben, you could jump in to talk a little bit about the ecosystem and its importance.
Yeah. So, yeah, Gordon, as you mentioned, we announced that in the second half, we're going to have our first ever Lattice Developers Conference. And the reason for that is based on, what Ben, you were mentioning earlier, which is, hey, the need for customers to have software solutions that can meet their, development needs are critical to their ability to innovate and accelerate their innovation. So, we're big believers in the ecosystem. We know that it's not just Lattice and our customers that are going to make this innovation happen. It's going to be alongside a number of smart organizations that that we need to make sure can utilize our development tools in an easy way, have access to our reference boards and our silicon. And at the same time, a lot of times they're business partners and they want to be able to utilize our FPGA platform as a channel for rolling out their own products, right? So those are all things that we know the ecosystem is super excited about with our existing Nexus platform and our new Avant platform. So we're super jazzed about that developers forum conference, in the second half of this year. Sorry. I'm still used to talking about 2022. This happens every January. So Ben, I really I gotta get the game here and start thinking more 2023.
Yeah, no worries. And it's interesting. I mean, I think, from my perspective, so much of our analysis on companies and technologies tries to really focus on competitive advantage and differentiation, which is why those are the parts of this that become really interesting to me. And I think we're on the cusp. Not to say that the industry itself was not highly competitive before, but I really do think it's going to get even more competitive in the years to come. And so that's why I think so many conversations keep coming back to really, what can I do to differentiate myself? What are the tools? What are the investments that companies can make to really set themselves apart from somebody else? And like I said, I think the limitations have always been, if you're subject to other companies' component roadmaps or the limitations that are provided to you by somebody else's components, you're just buying the same parts as everybody else. And in that world, you're really not that competitive. And so that's where I think this opportunity to use FPGAs to now do more in the mid to high end. And so it's encouraging that you guys are thinking about this, right, as a family. So it's not just Avant E, it's a range of other products that will come out. Is exciting because it's just, again, it's going to open up more and more opportunities in this category and give more people the opportunity to differentiate. And I think the developer conference is huge because, one, I think a lot of people, your customers, as well as many other potential customers, just need to really think about how best to use these things for their advantage, because I think these are new conversations, right? Understanding what you can do at a chipset level to differentiate, again, without having to develop your own CPU or your own NPU or GPU or something else, right, in the stack, but still be able to really set yourselves apart is so important. And I think developer conferences help do that, right? They show what the potential is for a market. They show vision. They show idea generation and just give people a taste of what's possible so that they can now take their products into a much more competitive level. Again, whether that's cloud, automotive, client compute. I mean, just lots of opportunities still coming to the industry. So I think that's good. I think it's an exciting time like I said, not just, FPGAs are cool again, but right, semiconductors as a whole is cool again. So it's a great space to be in, and I'm looking forward to the year ahead.
Ben, thanks so much. And we're just getting started. There's going to be a lot more coming from Lattice, both in terms of some of the innovations that we're going to bring to the market in our product portfolio, but also in some of the ecosystem applications that you were alluding to. And most importantly, it's really a privilege and an opportunity to work with so many great customers on innovating some of these new use models into their markets that they serve. So we're just getting started, and I wanted to thank both of you for spending the time with us today. It's been a pleasure for us to get your insights on what's happening in the market through your macro lenses. And as I mentioned earlier, we are going to be providing more information on our developers conference this year soon. So please stay tuned to the latest news and follow Lattice on LinkedIn, Facebook, and Twitter. And we hope to see you in our next our thought leadership panel. So thank you all for tuning in today. And again, Gordon, Ben, really appreciate your time.
Yeah, you're welcome. Really fun.